This section is on exponential and logarithmic functions. So this is something I've noticed that students are pretty uncomfortable with, and they're very common in calculus. So simplifying expressions, you need to know what the three different properties of logarithms are, and you need to be very comfortable with applying them. And specifically with natural logs, so we see ln a lot more than we see like actual logs with other bases. But if you are unable to simplify a log or recognize when the different properties can be used, then you might think you got the answer wrong on a multiple choice problem just because your answer is not simplified. And that's something that students have struggled with a lot. So that's the purpose of this section. First, we're going to go ahead and simplify. I could also tell you in this section to just evaluate, because I'm going to say like what the numeric answer is for a few of these, but simplify works as well. So the first problem is ln of the third root of e to the seventh. And so kind of the trick here, what I'm thinking of here is I know that ln and e are like inverse operations. They undo each other, like multiplying and dividing or adding and subtracting. So what I want to do is use what I know about radicals and exponents, so I can kind of get the ln and the e so that they're like next to each other so that they could cancel out. So I'm going to rewrite this problem as ln, and then I have the e, and I know that this, if I were to write it as an exponent, would be e to the 1/3 raised to the 7th, or I could say e to the 7/3. And so that means that the ln and the e cancel, and this would simplify just to be 7/3. Next, I'm going to do e to the negative ln of 1/3. So this one, the property of logs tells us that anytime you have a coefficient, that's actually an exponent. And so I'm going to rewrite this as e to the ln of 1/3 to the negative 1. And so now I can go ahead and say that e and the ln cancel out. And so this is 1/3 to the negative 1. And based on what I know about exponents, I know that this means I've got 1 to the negative 1 over 3 to the negative 1. And whenever I have negative exponents, it just means that I can move that base to the opposite side of the fraction. So this is really 3 to the 1 over 1 to the 1, which is just 3. Right? So this sort of thing you should be able to do without a calculator, because if you were doing this on the AP exam, you would not have one. But if you would like to check your answers and make sure that they are right, I'm putting e to the first on this one because inside it just has e, which means it's just e to the first. So I'm trying to type it in as close to the original problem as possible. Alright, that was a really long pause. I don't know if you guys caught that. So when I first typed it in, my answer was pretty wrong. I think what it was is I didn't have my parentheses quite right. So, sorry for the long awkward pause. I was like, I didn't do anything wrong. So what I did after that is I typed in the inside, and then I kind of did the order of operations myself. That's what I was doing. So let me type this in again and just make sure. I'm going to put extra parentheses this time. So I'm going to do third root of e to the first. There we go. So I think what it was doing before is it was saying this was the inside and the 7th was all of it. It was ln of the third root of e, and then that whole thing raised to the seventh, which is why the answer was wrong originally. I needed an extra set of parentheses. So that's cool. We learned something new today. All right, the next one, e to the negative ln of 1/3. Just when you guys thought you couldn't trust me, it turns out you can. All right, so those answers are good. Let's go ahead and do some more. Okay, so this one is not one that you can evaluate. This is truly just using the property of logs to simplify. So this is considered to be the expanded form of a logarithmic expression. So when I condense it down, I'm only going to write natural log one time. And then I have to remember what the properties are. So I remember if it says division, that means, or if it says subtraction, that means it's dividing. So this means I have ln of x divided by y. And anytime I have a plus, that means I'm multiplying by that step. So you could write times z plus 1. You could write it like that. But really that z plus 1, if we were to write it as a fraction, would be over 1. And so that z plus 1 would go on the top with the x. So it would be more common for you to write this as ln of x times z plus 1 over y. So what you really just have to remember is when you're writing a log and you have the properties, you're going to have a fraction over here. Anything with a plus, anything that's positive is going to go on the top of the fraction. Anything with a negative is actually going to go on the bottom of the fraction. And that's how you use your properties of logs. And then the other property to watch out for is what I used on this one, that the number in the front, that coefficient in the front is actually an exponent. That I would say is it's the easiest property, and it's one that students forget a lot, and that is the one that shows up all the time in multiple choice answers, and it's the reason why students can get these problems wrong if they don't have a calculator to compare decimals, and you probably will not have that as an option. All right, now I want to go through solving some exponential equations and log equations. So using exponents and logs as inverse operations is very common in calculus, and so it's got to be something that you are comfortable with. So first we have log base 2 of x plus 1 plus log base 2 of x plus 3 equals 5. So using the property of logs, I'm going to write the word log one time. And this says plus, and so that means these two things are going to be multiplied. So x plus 1, x plus 3. Now I can go ahead and FOIL that now. I can FOIL that later. It doesn't matter. So I'm going to go ahead and FOIL it now just to kind of clean up the problem. So x squared plus 4x plus 3. And now I've got a log on one side. I do not have a log on the other. So that means I need to get rid of that log. The opposite of a log is an exponential, and so I'm going to give this a base of 2. So now this is 2 to the log base 2, and then on the right side I have 2 to the 5th. So these cancel out, and I'm left with x squared plus 4x plus 3 equals 2 to the 5th, which is 32. And then I can go ahead and subtract the 32 over x squared plus 4x plus, it's going to be a minus 29. 29 is a prime number, so that means I'm not going to be able to factor this. I'm going to have to do the quadratic formula to solve it. So x equals negative b plus or minus the square root of b squared minus 4 times a times c divided by 2a. So negative 4 plus or minus square root of something over 2. So 29 times 4. 4 times 9 is 36. 4 times 2 is 8, plus 3 is 11. So what I have here is I've got 16, and then negative 4 times 1 times negative 29 is 116, so plus 116. So negative 4 plus or minus square root 132 over 2. And we can certainly go through and simplify that. I think this video is going to be long enough as it is, so I'm not going to. I just want to check and make sure my answer is right. So I'm going to go ahead and type this in. If I get this wrong, I'm really going to have to redo this video. So I'm going to type this in as x, and then I'll go ahead and do log base 2 of x plus 1 plus log base 2 of x plus 3. Make sure it equals 5, and it does. Woohoo! Ooh, that was good. And then I'm going to go ahead and just check the other answer. So I'm going to take this one, make that a minus. That's a -7. So what that means is that when I go to plug this in, -7 plus 1, that's a negative. -7 plus 3, that's a negative, and you cannot take the log of a negative. And I'll even show you if I try to plug this answer in now. Actually, I'm going to go ahead and store this as x. And then if I go back and I try to plug it in for x here, I'm going to get an error because you cannot log a negative number. So that means that when I go back and say what my final answer is on this problem, I have to conclude that it is only the positive version. Okay. All right. That was actually example 4, not example 5. All right, log base 5 of x plus 3 minus log base 5 of x equals 2. So again, I need to use the property of logs. So I'm going to say this is log base 5 of x plus 3 over x equals 2. To undo the logarithm, I need to give this problem a base exponent, right? So I'm saying that the inverse of logs are exponential equations. Those cancel. I've got x plus 3 over x equals 5 squared, which is 25. I can go ahead and multiply the x to the other side, so x plus 3 equals 25x. Subtract the x over, 3 equals 24x. Divide by 24. In a multiple choice answer, that would be simplified. In a free response, you could leave it. So here I'm going to say the top and the bottom are both divisible by 3, so that's going to give me 1/8. I can check my answer if I want to make sure that it's right, but I know that it's not extraneous, at least, because log base 5 of 1/8 plus 3 is taking the log of a positive number. Log base 5 of 1/8 is taking the log of a positive number, so at least it's not extraneous, but if I want to see if I got it right, then I really should plug it in. All right, example number 6. This time we're going to solve an exponential equation. So with this one, anytime I'm solving for x, I'm trying to undo the things that are around x so I can get rid of them. And so I need to undo the plus 1, but I can't because it's like protected that it's in the exponent. I want to undo the 3, but I can't. Again, it's protected. It's up in the exponent. So the first thing I need to undo is that base of e. Let's say maybe it had a base of 2 or a base of 7 or something. The way to get rid of a base is to do a logarithm with that base. So if this had been a base of 5, then I would do log base 5 on each side. If that had been a 2, I would have done log base 2 on each side. This is an e, so I'm going to do log base e on each side, which is why I'm going to ln each side. So ln is the opposite of e. So that gives me 3x plus 1 equals ln 10. And then I can go ahead and subtract the 1 over, so 3x equals ln 10 minus 1. This is not ln 9. The ln happens to the 10, it makes a funky decimal, and then with that result, then you subtract the 1. Right? And then I'll go ahead and divide by 3. So the exact answer would be ln 10 minus 1 divided by 3. The approximate answer would be whatever I get when I plug it in a calculator. You do not have to worry about extraneous solutions for exponential problems, but it's not a bad idea to check your answers, especially anytime you're doing calculus, because the answers often look kind of weird. Like we get a lot more messy answers when we're doing upper level math. Okay, one last problem for you. I want to look at another exponential equation, but one where it's a little bit more complicated. So this one is going to be 8 to the x equals 5 to the 2x minus 1. I would say that this is not the most common equation in the world, but it's going to use a method of solving that we've actually already seen in the summer assignment, and it's a method of solving that we are going to use in calculus. So with this one, I can't just log base 8 each side because that would get rid of the 8, but it wouldn't get rid of the 5. I can't just log base 5 each side because that would get rid of the 5, but not the 8. And so typically what we do here is we just log each side. And if you write the word log on each side, that means that you're doing a log base 10. Or I would ln each side. And in calculus, since we typically work with natural logs, that's what I'm going to do. You might not be comfortable with ln's right now, but by the end of the year you will be, because that's pretty much all we use. So I'm going to go ahead and say ln on the left, ln on the right. Now with the property of logs, it tells us that if we have an exponent, we can bring that to the front. So for the first part, I'm going to take the x and move it to the front, which is going to give me x ln 8. On the left side. And then on the right side, I'm going to take the 2x minus 1 and I'm going to move that to the front. So that gives me 2x minus 1 ln 5. Okay. At this point, my goal is to get the x's all to one side and get them isolated. So I need to get rid of these parentheses to do that because this x is being protected by that grouping symbol. So I'm going to distribute the ln 5. So I have x ln 8 equals 2x ln 5 minus 1 ln 5. And now I want to have the x's all on one side. So I'm going to say x ln 8 minus 2x ln 5 equals negative ln 5. And then to get the x's isolated, I'm going to take them out like a GCF. Only the x, because that's what I want to isolate. So this, I want to say we did this in the inverses section. The inverses and solving for y, I'm pretty sure I used this method in there somewhere. All right, so now to get the x all alone, we just have to take that parenthesis and divide it over to the other side. So x equals negative ln 5 divided by ln 8 minus 2 ln 5. And here it was an exponential equation that we were dealing with originally, so I don't have to worry about extraneous solutions. But since these answers are so funky, it's a good idea to just check them, make sure you got it right. So negative ln 5 over ln 8 minus 2 ln 5. I'm going to store that as x, and then I'll go ahead and type 8 to the x. And make sure that decimal matches 5 to the 2x minus 1. And it does, and so that means I got it right.